All right, we're going to look at one-step inequalities today. These inequalities look like the equations that we've solved in the past, look a lot like one-step equations. The big difference is that instead of having an equation with an equal sign, we'll have some less than or greater than signs. So let's look at the directions on our examples. Solve each inequality and graph its solution. Now, they've sort of put the graph right up next to this inequality, so the first thing I'm going to do is copy it down here just so I have some room to write. So in your minds, pretend that this is an equal sign. We're trying to solve for n. We want to get n by itself. So we're trying to remove the 2 from this side of the inequality. This works just like it did with one-step equations. We're going to subtract 2 from both sides. And that'll leave us with n and the less than symbol, and then 15 minus 2 is 13. So this is the solution, is n is less than 13. So any number that's less than 13 would be a solution. And the graph looks just like it did when we learned to graph simple inequalities in the previous lesson. So you go to 13, you'll make your point, but we do not fill it in because we don't have that little bar indicating that it's equal. It's just less than. So that's just where we're going to start. And then we will shade in all of the infinite solutions to this, and I like to shade in the arrow that just shows all of the numbers to the left of 13 are solutions that I could put in here. I could put 12 in here, and 12 would be less than 13. 11 is less than 13. 8 is less than 13. And this just shows that all the numbers forever this direction to the left of the 13 would be solutions. It's just a graphical way to show the solutions to this inequality. All right, let's look at number 2. Scoot this over a little bit. I'm going to copy it down here again just so it's neat. And we have 9b. We want to solve for b. We want to know what b is. Remember that 9b is the same thing as 9 times b. So if you want to put that little times sign in there, if that helps you think about it, that's totally okay. So to get rid of multiplication, we do the opposite, which is division. So we're going to divide both sides by 9. We get b is less than or equal to -4. And that is our solution. So if we look at this one, we do have that little equal to bar. It's b is less than or equal to -4. So when we put our point at -4, we fill it in, showing that -4 could be a solution, because -4 would be equal to -4. And then any of the numbers that are less than this also would be part of the solution. So anything to the left. And we talked a little bit in the previous lesson about when the variable is on the left-hand side, this symbol, this less than symbol, looks like an arrowhead pointing to the left, which is exactly what happens on your graph. It's sort of a cool connection to make. That's why the symbol is made the way that it is. It has to do with these arrowheads. All right, let's do number 3 next. So I have x over 6 is less than or equal to 17. Remember that this means divide. A fraction bar means divide. So to get rid of divide by 6, we will multiply both sides by 6. And we get x is less than or equal to whatever 17 times 6 is. And I'm going to be honest, I don't know what that is off the top of my head, so I'm just going to multiply that out to the side. So 7 times 6 is 42. Put down the 2, carry the 4. 1 times 6 is 6, plus 4 is 10, so that will be 102. So x is less than or equal to 102. Since we do have that bar indicating that 102 is part of the solution, we will fill in the point at 102, and then any number less than 102 is part of the solution. So that'd be 101, 100, 99, everything out to this direction, all the way off to infinity. All of these numbers would be less than 102. So this represents all of those infinite solutions that would make this true if we put the numbers in where the x is. All right, number 4. So I'm going to write this down. -3 is less than or equal to x minus 13. We're solving for x. It happens to be on the right-hand side this time, but that's okay. To get rid of minus 13, we would do the opposite and add 13 to both sides. So negative 3 plus 13 is 10, and then it's less than or equal to x. So it's a little tricky when this is on the right-hand side, especially if you were doing the thing I talked about with the arrowhead. First of all, I know when I put my point at 10, I can fill it in because there's that little bar saying that it's equal to. So at 10, I'm going to fill that in. And then trying to figure out which side we're going to shade, we can figure out using a test point. So let's say I take 9 and test that here. 10 is less than or equal to 9. Does that work? Well, think about elementary school. This is the alligator. Would the alligator rather eat the 9 or the 10? 10's bigger, so that doesn't work. So 9 is not part of the solution. Let's try a number on this side. Let's try 12. So if I put 10 is less than or equal to 12, does that work? Yes, because the 12 is bigger than the 10. And so that lets me know that the numbers on this side are the numbers that work. And so using a test point is a nice way to know that you've shaded the correct part of the equation. You can also take this inequality and flip it around and make it x is greater than or equal to 10. And then you could use the little arrowhead symbol, but it only works when you have the x on the left-hand side. Just as a little side note, when you flip these, you have to make sure that if it's open towards the x, it's still open towards the x when you turn it around. You have to flip everything that's in the inequality if you want to do it that way. Okay, there's one little twist that is different with inequalities compared to equations that we're going to look at here in a second. So we've got a statement down here on number 5. Solving inequalities is just like solving equations, except when you multiply or divide by a negative number, you must reverse, and if you would prefer, you could write the word flip the inequality symbol. Okay? And so that's a rule that we're going to use down here on number 6 and number 7. So if you multiply or divide by a negative number, you have to reverse the inequality symbol. So we have the same directions on 6 and 7. We're going to solve each inequality and graph its solution. So I'm going to copy this down here. Negative 7r is greater than or equal to 35. Remember, when this number is just stuck onto the variable, that means multiplication. So to get rid of that, we would divide. So divide both sides by negative 7. And we get r on this side, and we get negative 5 over here. Look at what happened to our signs. This is negative. When we divided by the negative 7, that side became positive. I had positive 35. When we divided by the negative 7, it became negative. Because that happens when you divide by a negative, this symbol has to flip. It was greater than or equal to. Now we're going to make it less than or equal to. And so that's the rule. It's because we divided by a negative, which means that we have to flip this inequality around. And it changes which part of the graph we're going to shade in. So if we find negative 5, that's between negative 4 and negative 6 right here, we'll fill it in because it does have that equal to bar. And we want the numbers that are less than, and those would go to the left. So when you divide by a negative, you flip this sign around, and that changes which side you're going to graph. And it has to do with these symbols. When you divide by negative, these signs all change, and it just flips everything to be the opposite. Let's look at number 7, our very last problem. So negative 64 is greater than negative 8n. Again, negative 8n would be negative 8 times n. So we're going to divide by negative 8. It gives us n on this side, and this would give us positive 8 on this side, since negative and negative have the same signs. Now look at what happened. I had negative signs on both sides of my inequality before. Now both of them are positive. Because everything reversed, we have to flip this greater than sign and make it a less than sign. Okay, so at 8, we're going to put our point. We do not fill it in because there's no equal to bar. 8 is not part of the solution, so this is sort of a non-point. And then let's, because the n's on the right-hand side, let's talk about which side this is going to be. Let's try something on the left-hand side. Let's try 7. So is 8 less than 7? No, that doesn't work. So I know that 7 and everything on this side is not the side that I want. Let's try a number over here. Let's try 10. Is 8 less than 10? Yes. So the numbers on this side of 8 are the numbers that are going to make the inequality true. And just like we talked before, you could also take this and flip it around and make it n is greater than 8. And if you put the variable on the left-hand side, then this symbol becomes the arrowhead, and it helps us figure out which side to shade as well. So a couple of different tools that you can use. The test point is a nice way to look at it, though, because then if you flip it around and you do it wrong, you won't make a mistake.